Right, well, a comment was left recently about perhaps to build a Cobble generator using a turtle. So I thought, okay, that sounds good. So I came up with this phenomenal piece of engineering here. And the way this works is that we have a turtle and a chest full of cobble, and if I click on the turtle itself, it's also full and it's waiting for me to take some stuff out, and every 10 seconds it will check to see whether the player has taken anything away. So what we can do is we can take a bunch of cobble from the chest, and then that starts to work again, and it will continue to work until it's generated another 64 cobble. So fairly efficient, quite quick. It's roughly 1 cobble per second, based on using 4 simple stone generators. The reason for using this way of doing it so that it produces stone rather than cobblestone is that apparently it's slightly quicker than the other method, which, depending where the water and lava meet, produces cobblestone. So that's going quite well, and any minute now, let's just check, that should reach 64 and then stop. There we go, inventory full, waiting for player. So the code works fine, and that's the generator, but fairly complex. So the idea of getting the turtle to build it is certainly not beyond the realms of possibility, but it's fairly complex. So I thought, okay, can we do something a bit simpler, beginning of game? Now you can hear from the speed that this one's going, it's much slower because we've only got a single cobble generator. The upside is that the turtle can hold 16 stacks of cobble, and each chest can hold whatever, 18, something like that, stacks of cobble. And the way this works is that it will continue to cut and drop the cobble in. So when that reaches 64, it passes it in to the chest in front. Now, because of the way the code works with turtles and chests, is that the ability to drop, if you use the drop command, returns a success rate of true or false. So if you can't drop because the chest is full, then that returns false, and you know, okay, that chest's full, we'll move round to the next one, and so on. So we could end up with, although its generation is much slower, an absolute ton of cobble. And this one, I think, would be fairly easy to get the turtle to make for itself. So I didn't need to use steps all the way around, but I did need to use them above the chests so that we can open them. But it looked quite neat, so I thought we can just sort of add some decorative ones on the corners. They're not really required, but it would help. Right, so here's the stages in building this manually before we start programming the computer. So we've got 4 single chests. Doesn't really matter which direction they face, but it looks neater to have them facing like that, and a turtle in the middle. Doesn't have to be an advanced turtle, just an ordinary one will do, and it doesn't need to be a crafting turtle either. So just one of the basic ones that you can make at early game. Then the second layer is the steps. So we'll go round. So we've got 1 step facing away from the turtle. That's where the water is going to sit. And then the others are all upside down. This corner one is for decorative purposes. This one holds back the new cobble when it's formed, corner decorative, and so on. So you've got these series of upside down steps around to give you that pattern. Now this next layer, I've deliberately left out the step at the back here because you can see that where this in turning step is, the water has been placed there. So it pours down over the top of the turtle. And then a series of steps are put in round, so the 4, 1, 2, 3 and the missing one there would hold the lava in, and the corner ones again are just for decorative purposes. So now that you've seen where the water is and that it's placed on the step, which acts of course as still as a water source, we can now finish that off by putting the final step in. So that gives us our finished one except for the lava. So with a bit of luck, if we now place the lava in here, as you heard it fizzed, so that has turned the or created the first piece of stone. Now at the moment the thing isn't running, of course. Let's just drop down so we can see. If we right click on it, and you can see that there's a block of stone immediately above it where that has done its job. So we'll run the Cobble generator here. Oops, helps if you spell it right. And it's checking through, checking each chest in turn, and then it's going to start to break the Cobble, as we've seen before. So I'll stop it at this point because it's noisy and irritating. So we've got two things. We need the code that will actually do this mining, and we also need, of course, to create it in the first place, although as you can see it's fairly easy to do manually. Right, so this is a completely new function or new code thing called Cobble. Now you could of course call it startup.lua, and then that means every time that the computer boots it will run this code. So you could have it so that as you are starting your game and as you're entering and leaving the chunk where your turtle is sitting, it would continue to work when you returned. So that's something you can do. So looks fairly complex, but I wanted it to run both for the superior design that you saw and this simple one. So as with all programs, they should start with a function main, which is this one, and the only bit that actually runs is this here. This is whether you're programming Python, Lua, whatever. Just use these functions and begin with one called main. In here, this controls everything. So the first thing we're doing is to check, is to state that this variable chest direction is forward and the dig direction is up. So that would assume that we have got the kind of setup that we have just made, where we are going to be digging upwards to get the cobble out, and that the chests are placed forward. Now this one here is using the turtle inspect down. Now that's to check whether I have the more superior design where there is a chest below it. If that's the case, then the chest direction will be changed to down and the dig direction will be changed to forward. Remember, by default its dig direction is up and chest direction is forward, so that alters things depending on where the chest has been found. So we now know which type of structure we're working in. Is it a simple 1 cobble generator, or is it a 4 cobble generator? Now this is an infinite loop. True is always true. There's no way of getting out of it. You have to terminate the program in order to get out. It's generally frowned on in programming, but this has a specific purpose. It's got to run forever, so maybe we can forgive that. Now the next thing we've got is a function called empty turtle, and it's taking the chest direction. So let's have a look at empty turtle. Right, here's empty turtle. Now not quite as simple as it seems, because this function called empty turtle has its own local function inside it called empty, passing this parameter drop. So that will be ignored when this function is first called. Now here is a bit of clever Lua stuff. You can use a variable which I've called drop. You'll notice with a capital D here because this variable is actually assigned to a function. So this is the turtle.drop function. As long as you don't put the brackets after it, then it won't actually do the drop. It'll just assign that function to this variable. And we're checking again, if the chest direction is down, then drop, instead of it being turtle.drop, becomes turtle.drop down. And that means that we can use this simple variable to mean either drop or drop down, depending on the situation. And then we've got here return empty and pass in the drop direction, which of course is this local function here within our empty turtle function. So what this one does is to take the drop command, which will either be drop down or drop forward, and do a simple for loop of the 16 slots that the turtle has. So these are numbered 1 to 16, and Lua is a 1-based language, so we don't use naught as you would do on a normal for loop in just about every other language I'm aware of. Then we do turtle select whatever that value of I is, so it would start off with 1 and then pass through till it gets to 16 within this loop. Then it says if the get item count, which is a built-in turtle function, in that slot is greater than naught, then what we're going to do is check whether we can drop it. So this slightly bizarre way of saying if not drop. So what that means is I want you to do a turtle.drop or turtle.drop down, and it always returns a true or false. So if for any reason it could not drop anything down, then it would return false. So we'd know then that the chest that it's trying to drop into or onto is full. So if we get a return false, then that breaks this loop, returns false, and quits this empty function. So it's either going to return false or it's going to keep going until it's emptied every single slot inside the turtle. When it's done, we reselect slot 1 so that we're ready to get more stuff in, and return, in this case, true, because we've emptied all the inventory slots in the turtle. So that's does its empty bit, and then assuming that that was successful, we've emptied out the turtle, it'll just simply return this back to the calling function. Now, that was if we were going down, but of course we're now emptying into 4 chests around the turtle, so it's slightly more complicated. So what we've done this time is to set up a Boolean variable called all full and set it to true. And then again we're using the success data equals turtle inspect. So success will say whether the inspection was successful, and the data will give you whatever kind of block that you've got in front of it. That's why inspect is the in front of the turtle. And then we're going to go round in a for loop again 4 times. So we're going to check each chest in turn. So if the data.name equals Minecraft.chest, that means we've got a chest in front of us. Then we're going to try and empty what's in the turtle into it. If we emptied everything, then we can say, okay, the all full, which we set up here to be true, is false because we've managed to empty the turtle. So therefore, all chests are not full. So we return, we make all full false. Then we turn the turtle right and do it again, so that we check again, have we got a chest in front of us, just in case you broke or removed one, and we don't want blocks being spat out of the turtle and just clustering up the countryside. If there's nothing in front of the turtle when you do a drop, it will just dump it out, and that's it. It goes all over the floor. So this will make sure that we're going to only dump if there's a chest. So then it turns right, so we do all 4 chests in turn. We're checking out whether they've got any space in them. Even if there's 1 space in 1 chest, all full will be false. and then we're going to return either true or false, everything's full, or no, there's still plenty of room. So that's this kind of very complex empty turtle function which we did down here. So that's the first thing we do. We emptied the turtle, and assuming that that came back as true, the turtle is empty, we're ready to go, then we're going to run this routine 16 times, which is to get Cobble in the dig direction. So we're calling yet another function. So the get Cobble dig direction. So if we're digging upwards, in other words, as we are in our quick and dirty, cheap, early stage Cobble generator, then we're digging upwards. Then what we're going to do is to dig 64 and then exit this routine. So we start off with a local variable called count set to 0. And then while count is less than 64, we're going to do this routine here. So that says if turtle detect up. Now if you do a detect up on water or lava, it's false. But any other solid block will be true. So if we detect up, then we dig up, and then the count is increased by 1. So as long as that's being generated, that count will increase. Now if you took away the water source or the lava source, once you dug up, it's never going to detect up. So this would never break, but then your generator's broken anyway, so it really doesn't matter. So this will count up until we've reached 64, and then it will quit. We've gone out of the routine. We've dug 64 Cobble. Now let's say, for example, down here that we had when we tried to empty the turtle, it failed. There's still some stuff in the turtle, it can't dump it. It's then going to check whether the inventory count inside the turtle is still got some space in it, because if you remember when you saw it in action, it really only fills up one slot and then dumps it out into the chest. So we're now going to use this get inventory count function to see whether we've got any space. So the get inventory count is quite simple. We set a local variable count to 0, and then again we're going through all 16 slots in the turtle and increasing the count by whatever the item count is in that specific slot. So if we've got 64 Cobble per slot and there's 16 slots, that's 1024 possible blocks to be filled. So this will return whatever's available in the turtle. So if we come back down to here, if it's less than 1024, then we've still got some space in the turtle. We're going to go and get some more Cobble. But this time we're only doing it in 4 only. Actually, is that true on this one? No, I think the dig direction is still going to return 64. Anyway, it doesn't matter. So we've got 64 Cobble going to be retrieved again. Otherwise, we're going to print inventory full, waiting for player, and then sleep 10. So what happens then is this while true is still running. So this goes round and round and round. So we've now got a full inventory. It slept for 10 seconds. It comes back and says, if empty turtle, no, that failed. If the inventory count less than 1024, no, that failed. Print inventory full, waiting for player. Sleep another 10 seconds. So this will just sit there and sit there and sit there until the player empties it, or you go out of the chunk, or you Control T and terminate it. So that's how this works. And as you saw, it's fairly successful, but it was designed to run on 2 different setups. So this works on both of those. So a little bit of programming for you there. This is what makes Computercraft fun. It's very logical, it's very sensible. Lua is a fabulous language. Python sucks, but this is great. So that's the code, and we're now going to try and move on to actually doing some even more complex code to build the Cobble generator.